Hey, I wanted to share some more practice questions with CPI, inflation, when you have a table that looks similar to the one that's on the screen. So you can pause, obviously, at any time to work the questions out yourself, but I wanted to show you how to work each step and then what the answers to that would be. And I think I just scratched my face and then it froze on my face for a while, which is awesome. So when you are solving for nominal GDP, it's a simple calculation of how much money do they make that year. So for year one, they have $2 apples and they sold 10 of them, and then $3 bananas and they sold 12 of them. So we're just multiplying and then adding. So 10 times 2 plus 12 times 3, nominal GDP for year one is going to be $56. While year two, it's the same type of math. 15 times 3 plus 12 times 4, and I'm cheating because I've done the math already. I'm just looking at my answers, is $93 for year two. And year three, nominal GDP, same type of thing. 20 apples times $6 plus 15 bananas times 5 is going to give you $195. So our first three answers for year one, year two, and year three, nominal GDP was 56, 93, and 195. To calculate CPI, you're going to be using this equation. So the CPI is equal to the market basket price of the year you're talking about divided by the market basket price of the base year. Multiply that all times 100, you're going to get CPI. So here's that equation. CPI is the market basket price of the year you're talking about divided by the market basket price of the base year. And all that times 100. So this first year, year one, we are using that as the base year. So that the base year price, the base year market basket, if you remember, was $56. So this first box down right over here should have been $56. So that's going to be our denominator for year one, year two, and year three, because that doesn't change. The base year is year one. And so we're just trying to figure out what goes on the numerator. So for year one, I changed markers trying to figure this out. Okay, so in year one for CPI, you're going to use year one market basket on the numerator, which was 56, divided by the base year market basket, which was also 56, because that's the same year, times 100. Well, 56 divided by 56 is 1, times 100 is 100. So the year one CPI is going to be 100. And I also know that didn't require any math because the base year CPI is always 100. That's what makes it the base year, is that we're converting everything into that year's prices. I'm changing my marker again. Hopefully I get a color that works for us. Year two, though, is not going to be 100 for the CPI. Year two, I use the market basket price for year two in the numerator, which is 93. That was the number that was in this box down here, divided by the market basket price of the base year, which was 56, times 100. So it's 93, that's the market basket price of year two, divided by the base year market basket times 100, and that is going to be equal to 166. So the CPI in year two is 166. Year three, same type of formula. You're using the market basket price from year three, which was 195, divided by still the market basket price of year one, which is the base year, which is 56, times 100. And that's going to give you 348. So this is the CPI of year three. There's the market basket price of year three divided by the basket price of the base year times 100. That's your CPI for year three, 348. Okay. To solve for real GDP using a table like this, you're not going to be dividing by like CPI or anything like that. You're going to be using the prices of the base year. In this case, can I highlight? Do I have a highlighting tool? Oh no, I went backwards. No, all my tools here. Here we go. Let's turn on the laser pointer. Sure, let's do that. We're going to use the prices of the base year, which we're still using year one as a base year. That's $2 for apples and $3 for bananas. So those are my constant prices that I'm going to be using for each time I solve for real GDP. So apples cost 2 and bananas cost 3. Okay, so those are constant prices. Apples cost $2, bananas cost 3. And so to solve for real, you use the quantities of the year that it's asking for. So quantities of year 1 or quantities of year 2 or quantities of year 3, but we're keeping the prices base year prices. That's going to remain constant. That's why real is called constant. So for year 1, well, year 1 is actually pretty simple because year 1, the nominal and real are the same because that's the base year, plus those are the prices that year. So it's still the same math that we did to solve for nominal. So it's going to be still 10 times 2 plus 12 times 3. So it's 56 for year 1. So the year 1 real is $56, which was exactly what the nominal was. And that's always true when it's the base year. The real and nominal are going to be the same. For year 2, though, is going to be different because we're using year 2 quantities, but year 1 prices. So year 1 prices, remember, are $2 and $3. $2 for apples and $3 for bananas. But we're going to use year 2 quantities, which was 15 apples and 12 bananas. So it's going to be 15 times 2 plus 12 times 3. And that's going to give you a total of 66. So year 2 real is $66. And year 3, once again, you're using the prices of the base year, which is $2 for apples and $3 for bananas, but the quantities of year 3. So the quantities of year 3 are 20 apples and 15 bananas. So it's 20 times $2 plus 15 times $3, and that's going to give you 65. So year 3 real is 65. So you actually see that the economy really did grow from year 1 to year 2, but from year 2 to year 3, the economy actually shrank from $66 to 65. So the reason that it went so high up in nominal when we did that is because inflation has really gone up. But the quantities really haven't changed. In fact, they dropped. Right? Well, actually, no, they didn't drop. The quantities still went up, but they didn't go up as fast as prices did. Prices went up at a higher rate than the quantities, and so the real actually fell. And last bit, we're going to calculate inflation. Now we're using 2 different CPIs. So if you remember, our CPIs were 100 for year 1, 166 for year 2, and 348 for year 3. So this was our 3 different CPIs, and we're calculating inflation with that no formula. It's a percent change between CPIs. New minus old divided by old times 100. So new minus old divided by old times 100 is going to give you percent change. And if you have percent change between CPIs, you have inflation. So from year 1 to year 2, we're going to be solving for the percent change. So it's 66 minus 100, which is the old one, divided by 100, which is the old one, times 100. Well, since it's coming from the base year, it's actually just a subtraction problem since it's coming from the base year, since those hundreds are going to cancel out. So it's just 66% inflation from year 1 to year 2. But going from year 2 to year 3, it's not just a simple subtraction anymore. We really have to work this formula out. So it's 348, which is the new CPI, minus 166, which is the old one, divided by 166 times 100 is going to give you that percent change. And look, that it's the number that you get is 109.6. I think. Is that right? I just got to confirm my answer. 109.6. I believe that's right. That is a lot of inflation. Yeah, no wonder real fell. The nominal really only went up because inflation went up so high. And so that is the inflation rate. Prices basically doubled and then some, because 100% is doubling. So it went up double and then a little bit more than double in that last year. So hopefully this answers any questions that you have, gave you some more practice, and prepare to see, similar types of questions in the future. Have a good day, everybody. If I can learn how to pause this. There's all my tools. That's what I was looking